In today's notes, we're going to be looking at partial fractions with repeated linear factors and also quadratic factors. If we take a look up here at the top, it says if the denominator of a rational expression has a linear factor that is repeated n times, the partial fraction decomposition must include a partial fraction with its own constant numerator for each power 1 to n of the linear factor. For example, to find the partial fraction decomposition of this right here, you would write. So what I want you to notice in this is that we have an x raised to the third. That means we have a factor of x 3 different times. X minus 1 to the second means that we have x minus 1 twice. So what it's saying is that we have to represent each one of those factors. So again, to think about the denominator of this function right now, we have x times x times x times x minus 1 times x minus 1. So how that would be written down is we would take a over x, and then we would increase that exponent by 1 until we get to the number 3. So we would do b over x to the second. Oops. Let's try that again. Plus c over x to the third. So because this x is repeated 3 times, we need 1, 2, and 3. If this was an x to the fourth, it would be 1, 2, 3, and 4. Now our x minus 1 to the second, there's 2 of them. So then we would add on here a d over x minus 1. And then we'd have to do e over x minus 1 to the second. So we would have to get each one up to 2. So any repetitive linear factors, you must work at that exponent all the way up to the one that you have. Now let's take a look at example 1. We want to find the partial fraction decomposition of negative 4 over x to the third plus 2x squared. So let's factor this out. This factors into negative 4 over, in the denominator we can factor out an x squared, times x plus 2. And then what we want to do is we want to write it out. Remember our x squared that we have, that's a repetitive linear factor. So we have to represent not only x but also x squared. So we would write that as a over x plus b over x squared. And then we also have a linear factor of x plus 2. So then we have c over x plus 2. Our next step then is to multiply by the least common denominator. And our least common denominator right now is x squared times x plus 2. And if we go and multiply by that least common denominator, if I multiply this whole thing here by the x squared times x plus 2, this whole denominator is going to cancel out with that, and I'm going to be left with just negative 4 equal to, if I take a over x and multiply it by here, this x will cancel out just one of these x's, and I'll be left with a times x plus 2. Then if I take b over x squared and I multiply it by here, the x squareds will cancel and I'm going to be left with just the x plus 2. So I have plus b times x plus 2. And finally, if I take c over x plus 2 and multiply it by the least common denominator, the x plus 2's will cancel and I'll be left with just an x squared. So I get plus c x squared. Then from here I'm going to multiply it out. Ax times x is ax squared. And then ax times 2 will give me a positive 2ax. Multiplying my b times x would be bx, and b times 2 would be 2b. And then I still have my cx squared. Then I want to group together my x's, my x squareds, and my constants. So if I look for my x squareds, I have ax squared and cx squared. So let's group those together. Ax squared plus cx squared. Then I'm going to group together my x's, which are these middle ones here and here. And I get 2ax plus bx. And then my constant, which is just 2b. In my first set of parentheses here, I can factor out the x squareds that come into both. And I get x squared times a plus c. In the second one, both of these have a common x that I can take out. And this is multiplied by 2a plus b. And then I still have my 2b as my constant. Remember that this is equal to -4. And in terms of we have x squared, x's, and a constant, I'm going to rewrite this -4 to look like the following. We have 0x to the second plus 0x minus 4. And that's just going to help because as we look at this right here, this a plus c, that's got to be the coefficient in front of our x squared. This right here, this 2a plus b, that's going to be our coefficient of x. And our last part, this 2b, that's our constant. So what we can do is we can set up our system of linear equations. So we have a plus c, since that's our coefficient of x squared, that has to be equal to 0. So we can say a plus c equals 0. Then this 2a plus b, that's our coefficient of x, which has to be 0. So 2a plus b has to equal 0. And then finally, this 2b, that has to be our constant, which is -4. So we know 2b has to equal -4. Well, if we start to solve this system, using this last equation, if 2b is equal to -4, then we know that if 2b equals -4, that we know b is equal to -2. And if b is equal to -2, we can use this middle equation to solve for a. So 2a minus 2, we can substitute in the b value, is going to be 0. Then we know 2a has to equal 2, so a is 1. And if a is 1 and a plus c is 0, then c has to be -1. Now that we have all our numbers, a, b, and c, we can go and put them in for our final answer. So I'm going to do that down here. Here's my answer. So again, I'm coming back all the way to the top here. And I'm going to plug in my a, my b, and my c value. So that means my answer is I get 1 over x plus -2 over x squared plus -1 over x plus 2. If you have any questions, please let me know.